Okay, so this is going to be the second video in the series about ratios, rates, and proportions, okay? In the first video, we talked about what a ratio is and how to simplify a ratio. In this video, we're going to focus on rates, okay? So just a quick recall. Actually, let me change to a color that you can see better. Okay, so recall. A ratio is a comparison of two quantities. All right. For us, we will express them in fraction form. All right. And you always want to make sure that the ratio is simplified. Now, in the previous video, we discussed different ways, or not really different ways to simplify, but we looked at lots of different ratios and how they would look once they were simplified. And a couple of things came up. Do not write ratios simplified as decimals whole numbers, or mixed numbers. So for example, if you had a ratio, let's say we had 15 to 10, and it's simplified as 3 to 2, you really do have to leave it 3/2. You do not want to write this as 1.5 or 1.5. This would be horrible, terrible, awful. Don't do it. The whole definition of a ratio is that it's a comparison of two quantities. We need to make sure we have this as an improper fraction where you can see the two distinct quantities. Our quantities are 3 and 2. If you write your answer as a mixed number or as a decimal, you lose that comparison. Now, for this video, we're going to talk about ratios, rates. So we're going to talk about a rate. A rate is a special type of ratio where the two quantities being compared have different units. So rates are just special types of ratios. The only thing that's different is the two quantities that you're comparing definitely have different units, okay? And because you have different units, it's very important to keep the units in the final answer. I'm going to give this 2 exclamation points because it's that important. This is something students get really frustrated with. They'll take a ratio, they write it in fraction form, they simplify it beautifully, but they don't tell me which number corresponds to which unit, and they end up getting points knocked off, which is heartbreaking. So make sure that the units are in your answer. If you're comparing dollars to donuts, one number has to be $1, the other number has to be a donut, and you need to specify which is which by including those units in your final answer. So let's look at several examples. We're going to start with some really, really easy examples, and then we're going to look at special types of rates called unit rates and unit prices. But for now, we're just going to simplify the following rates. Whoops. All right. So for the first example, we have 2 teachers to 24 students. Now, even though teachers and students are both people, we're going to specify the difference between these people, and we're going to talk teachers versus different people, students. So the units here matter. So I would start with 2 teachers for 24 students. So you start by writing your answer in fraction form, and then you want to reduce. So 2 and 24 have a 2 in common. 2 divided by itself is 1. 24 divided by 2 is 12. So our final answer would be that there's one teacher. Whoops, go back to the darker ink that's easier to see. Our final answer is that there's one teacher for every 12 students. Those units absolutely must be in your final answer. If you wrote this as just plain old 1 to 12 or 1 over 12, it wouldn't be exactly correct. All right, let's look at another example. Let's say that we had 90 wins to 72 losses. All right, so we're comparing wins to losses in some type of a game. So we start with 90 wins over 72 losses. All right, you then want to go ahead and start reducing, and this is one where reducing it might be a little bit difficult. So let's say that you realize both of these numbers are divisible by 2. They're both even. 90 and 72 are both even, so you know they're divisible by 2. So 90 divided by 2 is 45. 72 divided by 2 is 36. So let's clean this up a little bit. So for now, I've got 45 over 36. I know these are both divisible by 3. So 45 divided by 3 is 15. 36 divided by 3 is 12. Well, let's see, they're both divisible by 3 again. So we have 15 to 12. They're divisible by 3 again. 3 goes into 15 5 times. 3 goes into 12 4 times. And our final answer would be 5 wins for every 4 losses. All right. So in that case, again, would we want to write this as 5 1/4? Absolutely not. We want to leave this as an improper fraction. So 5 wins to 4 losses. Now, if right off the bat you saw a larger number that would divide into 90 and 72, use it. I just wanted to remind you how to reduce if you had larger numbers that you didn't find the greatest common factor for. Let's look at another example. Let's say we have a bake sale and we've decided to make 15 cookies and 18 brownies. So we would start with 15 cookies over 18 brownies. And we would reduce. 15 and 18 both have a 3 in common. 3 goes into 15 5 times, into 18 6 times. So our final answer would be for every 5 cookies that we make, we want to make sure that we have 6 brownies. And that's our final answer. Just make sure you always include those units with your final answer. Let's look at another one. Let's say that we have $285 for 18 trees. Looks like you're doing some landscaping here. So we would start with $285 over 18 trees. Well, let's see, 285 and 18. Let's figure out what they have in common. Okay, so what you would want to do is you would start looking at the 18. Look at factors of the smaller number. Well, 18 does not go into 85 evenly. So then you start thinking of all of the factors of 18. So 285 is not divisible by 18. We've checked it's not divisible by 19, or not 19, by 9, pardon. We want to try 6. 285 is not divisible by 6. So then we want to try 3. And 285 is divisible by 3. So again, if you've got large numbers like this and you need to reduce, look at the smaller number. In this case, that's the 18. And start dividing the numerator by factors of the larger number. So 18 did not go into 285. 9 did not go into 285. 6 did not go into 285, but 3 did. So both of these numbers are divisible by 3. 285 divided by 3 is 95. 18 divided by 3 is 6. So this would simplify to $95 for every 6 trees. And that would be your reduced ratio. Now, when you're reducing ratios, you're just reducing like you would any other fraction. All right. Okay, so next up, that's just simple reducing ratios. Next up, we're going to look at special types of rates. So remember, rates, they're just a special type of ratio. They simplify just the same way that ratios do, but now we're going to look at special types of rates. These special type of rates do have their own rules. Okay, so we've got special types of rates. The first special type of rate is called a unit rate. And the second special type of rate is called a unit price. All right. So I'm going to split that up a little bit and we'll look at them side by side. Okay. So a unit rate is a rate where the denominator is exactly 1. A lot of times in math, when we use the word unit, we really just secretly mean 1. So what's happening here is if we were to go back to this slide right here, and let's say we looked at this example, okay? The unit rate would be the rate where we found out exactly how many dollars it costs for 1 tree, all right? So this is going to be a little different over here. We're going to find out exactly what would happen if the denominator was 1. All right. And because we're forcing our denominator to be 1, we can have decimals. So decimals are allowed in the final answer. All right. Now the second special type of rate is called a unit price. And this is a special type of unit rate. All right. And this is a unit rate involving money. So again, if I go back to the previous slide, if we look at this example with the tree, all right, if I wanted to find the unit rate, or in this case, the unit price, I would want to know the cost for exactly 1 tree. Okay, so basically, to find unit rates or unit prices, divide both the numerator and denominator by the denominator. And let's look at an example. Okay, so again, ratios are just comparisons of 2 quantities. Rates are special types of ratios where those 2 quantities that you're comparing have different units. And then we have special types of rates called unit rates. Unit rates are a rate where the denominator is exactly 1. Decimals are absolutely permitted in the final answer. And then we have this second special type of rate called a unit price, which is really just a special version of the unit rate. And the only thing that's different between a unit rate and a unit price is that a unit price involves money. To find unit rates or unit prices, you divide both values in that ratio by the denominator. So let's look at some examples. So the directions you do need to read. So finding a unit rate is different than finding just a rate. All right, if you're simplifying just a rate, the denominator does not have to be 1. If you're asked to find a unit rate, the denominator has to be exactly 1. So let's say you have an urn of coffee that holds 10 cups, and you've got 6 people drinking coffee from this coffee urn. We want to know how many cups of coffee does each person get. So if we add 10 cups of coffee for 6 people, if we were just simplifying the rate, we would just reduce this and we would get 5/3. That would mean there would be 5 cups of coffee for every 3 people. But in this case, we want to find the unit rate. That means we want the denominator to be exactly 1. And the way to get this denominator to be 1 is to divide it by itself. Now, if I divide the denominator by something, I have to divide the numerator by the exact same value. All right, so 10 divided by 6 is 1.67, we'll say. I'm just going to round it to 1.7. So for every person, there's approximately, and I am going to make this an approximately equal sign so we know that we rounded. There's approximately 1.7 cups of coffee for each individual person. All right, so now you could also write this, instead of writing it as just like a regular fraction, you could write this as 1.7 cups per person. All right, you'll see either of them. I tend to do this, but both of these are exactly the same. All right, let's look at another example. So let's say 8 ounces of soup has 176 calories. So 176 calories for 8 ounces of soup. So basically what we want to know, if there's 176 calories for this entire 8 ounces of soup, we want to know how many calories are in each individual ounce. So I start by converting this to a fraction. And then I divide the numerator and denominator by the value in the denominator. So 176 divided by 8 is 22. And then 8 divided by 8 is 1. So that tells us that there are 22 calories per ounce of soup. Let's look at another example. I'm trying to find a good one. Okay, let's say there are 370, good grief, I can't speak, 375 riders for 3 subway cars. So what we want to know is how many people on average are in each individual subway car. So we start with a fraction, 375 riders. I got it right that time. 3 subway cars. We want to divide numerator and denominator by the value in the denominator. So 375 divided by 3 is 125. 3 divided by 3 is 1. So that would tell me that there are 125 riders per subway car. All right, let's look at a couple more just to make sure we're totally good. Let's say that a hummingbird has 5,820 wing beats in 1 minute. Now, this already looks like it's a unit rate, and it could be considered a unit rate. So 5,820 wing beats in 1 minute, but let's look at this as 1 second. So I'm going to change this 1 minute to 60 seconds. So then we would want to find the unit rate of how many wing beats in a single second. So I get 5,820 wing beats in 60 seconds. I want to divide numerator and denominator by the value in the denominator. 5,820 divided by 60 is 97. Excuse me. So that's 97 wing beats per second. And that's it. So again, be really careful. Sorry, I had to get water. Be really careful, read the instructions, make sure you're either just simplifying a regular rate or you're very specifically finding a unit rate. And a question like this one with the wing beats in a minute and then really finding the unit rate per second, just read the directions. The directions would specify really clearly what you were expected to do. Let's look at another one. Let's say your car requires $760 to travel 1,520 miles. So we want to know the cost to travel per mile. So we would start with 760 over 1,520 miles, divide numerator and denominator by the value in the denominator. And let's see, 760 divided by 1,520 is 0.5. So that tells us it's 50 cents per mile for whatever kind of traveling you're doing. So again, we were asked to find unit rates. You have to force that denominator to be 1, even if you end up with a decimal like we do here. The decimal is permitted now. All right, let's look at another one. Let's say it costs 2.6 million to build 40 houses. All right. So if we want to find the unit rate, we want to know the cost to build a single house. So we take our 2.6 million, bless my heart, and we're going to divide it by 40 houses. And then we divide numerator and denominator by the value in the denominator. And the 2,600,000 divided by 40, we get $65,000. And then the denominator, 40 divided by 40 is 1. So that tells us the cost to build one house is $65,000. Let's look at another one. So for this one, we have assembly line products. There are 18,000 good assembly line products to 60 defective products. So we have 18,000 that are good. We have 60 that are bad or defective. So we want to know the unit rate here. How many good for every bad? So we divide numerator and denominator by the denominator of 60. 18,000 divided by 60 is 300. So for every 300 good products, you could expect 1 bad product. And there's your unit rate. So again, read directions carefully, see if you're just simplifying the rate versus finding the unit rate. All right. Now, next up, let's find unit prices. Now, on the previous slide, we did find a few unit prices. This right here would technically be considered a unit price. It's just the cost per home. This would technically be considered a unit price. It's the cost per mile to travel. We're going to do some more of that. You already know you can do it because we've done it already. So let's look at some more examples. Let's say it costs $40.50 for 5 shirts. We want to find the unit price. You take the price and you can divide it by the units. And let's see, $40.50 divided by 5, that's going to give us $8.10. Now, when you are dealing with money, you do always have 2 decimal places. There could potentially be an example here where you might need to go out 3 decimal places, but for this one, 2 decimal places is perfect. So it's $8.10 per shirt. Let's look at another one. Let's say it was $1.49 for 9 ounces of bread. So we want to know the cost. The unit price would be the cost per ounce. So we take $1.49, we divide it by 9 ounces. So $1.49 divided by 9, and we would get, you want to round here. Okay, so if you type this into your calculator, you're going to get 0.165555555 repeating. So we're going to go ahead and use the approximate equal. So that's just kind of the wavy equal sign. All right, $0 point. We want to round this. So we're going to say it's approximately 17 cents per 1 ounce of bread. So be ready to round, okay? And you always want 2 decimal places. So if we looked at this, we got 0.16555555 repeating. You want to round this value right here. This digit to the right tells us that we need to round up. So I add 1 to the 6 and then chop everything after that off. Let's look at another one. Let's say that we had $1.73 spent on 16 ounces of juice. All right, so we want to take the price divided by the unit, which would be 16 ounces. So let's see, $1.73 divided by 16 gives us 0.0125. So again, we get I think I said 0.108125. We want to round this as if it was money. So we're interested in the second digit here. The digit to the right tells us to round up. I'm going to go ahead and use a wavy equals. This is going to round to approximately 11 cents per 1 ounce. All right, so be ready to round. It happens a lot. All right, one more example, and then we're going to move to the last situation for this video. Let's say we had 200 napkins for $1.89. Now, regardless of the order of how this is written out, we want to go ahead and do price divided by units always. So unit price, it's always price divided by units. It does not matter that napkins came first in the problem. It's price divided by units. All right, so we take both, divide it by 200. So let's see, $1.89 divided by 200, we get 0.00945. Now we're talking money. So we're interested in this second digit here. The digit to the right tells me to round up. So that tells me that these napkins are approximately 1 cent per napkin. They're actually less than that, but that's how it's going to round, approximately 1 penny per napkin. Okay, so that's unit price. So quick recap. Recall that a ratio is a comparison of any two quantities. We express them in fraction form. We write ratios in their simplest form, but we do not write ratios as simplified as decimals, whole numbers, or mixed numbers. We have to maintain that comparison of two quantities. That means our final answer needs to be a fraction. All right. Now, for this video, we're specifically talking about rates. Rates are a special type of ratio where the two quantities being compared have different units. You must keep the units in your answer. All right, we looked at just simplifying rates. Now, when you're simplifying rates, you just reduce, okay? Your denominator does not have to be 1. You just simply reduce it and make sure you keep your units in your answer. All right. Now, then we talked about two special types of rates. The first special type of rate is a unit rate. And a unit rate is a rate where the denominator is 1. Decimals are now allowed in your final answer. The second type of rate we look at is called a unit price. It's just a special type of unit rate. That means you want your denominator to be 1. The only difference between a unit rate and a unit price is with a unit price, you're specifically dealing with money. So to find a unit rate or a unit price, divide both the numerator and the denominator by the value in the denominator. All right. We looked at some examples of finding unit rates. We looked at some examples of unit rates again. We finally did some examples of unit price. And the last thing I want to do is look at a better by comparison. This is kind of the classic application. I think I spelled it wrong. This is the classic application where you're dealing with rates, okay? So imagine going to the grocery store. And there are 2 items that are similar, 2 jars of pickles, 2 types of soda, 2 types of chips, 2 types of strawberries, 2 types of whatever. All right. And they're different sizes and they're different prices. If you want to save money and get the best buy, the most bang for your buck, all right, you want to look at the unit price and basically compare unit prices. So this is a simple comparison of unit prices on similar products. All right, so let's look at an example, okay? Let's say we have dry pasta, so penne, rigatoni, spaghetti, whatever kind of dry pasta. The first dry pasta we look at is 18 ounces, and it costs $2.16. The second type of dry pasta is 27 ounces, and it costs $2.97. Now, just because the first pasta is cheaper overall doesn't necessarily mean it's the better buy. So you always want to look at this as the cost per ounce. So we're going to find 2 unit prices. So we're going to look at the 18-ounce box first. We take the price, $2.16, and we divide it by the number of ounces. All right. We divide top and bottom by 18. $2.16 divided by 18 is 12 cents per ounce. So that's our first unit rate. Now we want to look at our second box of pasta. So we have the 27-ounce box. We're going to do the same thing. We're going to take and find the unit price. That's $2.97 divided by 27 ounces. This was actually exactly equal. So let me put the regular equal sign here. All right, so $2.97 divided by 27, and we get 11 cents per 1 ounce. So looking at these two, which product is cheaper per ounce? This right here is cheaper per ounce, and it equals the better buy. So even though on the surface this product costs more, it's $2.97, which is obviously more than $2.16, you get more pasta in the box, and each ounce of pasta actually costs less. It's less by 1 penny per ounce. So in this case, the better buy is going to be your 27-ounce box of pasta. Let's look at another example. For this one, let's say we have crackers, Ritz crackers, saltine crackers, I don't know, just some kind of crackers. Gracious. There we go. So this time we're looking at crackers. The first box of crackers is $1.09 for 15 ounces. The second box of crackers is more, it's $1.49, but it's also more ounces. So we have to go deeper. We have to look at the unit price to figure out which product is actually cheaper. So let's look at the 15-ounce box of crackers. We take the cost, $1.09, we divide it by the ounces. And then we're going to do the same thing for the 20-ounce box. We get $1.49 for 20 ounces. So we find each unit price. Let's see, $1.09 divided by 15, $1.49 divided by 20. So for these, I'm going to go out a few decimal places. I want to write this out so we can kind of look at it. For the first one, when we do the division, 109 divided by 15, we get 0.072666 repeating. For the second box, $1.49 divided by 20, we get 0.0745. What I'm going to do is I'm going to go out 3 decimal places, because if I round these mathematically, they both round to 7 cents per box, but one box is still more. So this time we're going to look 3 decimal places out. All right. So 0.072 is going to round to approximately 0.073. All right. And then the 0.074, when I round it, we're looking at this number right here. The digit to the right in both cases told us to round up. So this one is approximately 0.075. Which of these values is bigger? This value here is bigger. All right. So it tells us this box, the 20-ounce box, is almost 8 cents per ounce, whereas the 15-ounce box is a little bit cheaper. So this one is 0.073 per ounce. This one is 0.075 per ounce. This one is cheaper. So the 15-ounce box of crackers is actually the cheaper product, barely. The difference in price per ounce is tiny. So both boxes, at the end of the day, the cost between them is negligible, but technically by just a smidge, the 15-ounce box is cheaper. Okay. So there you have it. That would be the video on rates. So remember, We already did a video on ratios where we talked about how to set up a ratio, how to simplify a ratio. This video, we just really focused on rates. The big thing is it's still a comparison of two quantities. So you need to make sure that the distinct quantities are differentiable. Like you can look at them, you can see that one is different from the other. So all the rules for simplifying ratios applies to simplifying rates, with the exception of unit rates. Unit rates, you can go a little deeper because you're forcing that denominator to be 1. So decimal answers are acceptable for unit rates or unit prices, okay? Make sure your final answer has units. Other than that, best of luck. And the next videos, I think we'll talk about proportions.